Hey everybody, welcome to Smart Software with Smart Logic, a podcast where we talk about best practices in web and mobile software development with a focus on new and emerging technologies. My name is Justice Epen, and I'll be your host today. I'm a developer here at Smart Logic. We're a Baltimore-based consulting company that has been building custom web and mobile software applications since 2005. Joining us is special guest Brooklyn Zelenka from the Special Projects and Decentralized Engineering Company, or SPADE. How are you doing today, Brooklyn?
I'm doing very well, thanks.
Great.
How are you doing?
I'm doing lovely. And we're also joined by one of my colleagues, the infamous Eric Ostrich. How are you doing today, Eric?
Pretty good.
Awesome. So we're going to jump right into it. Our first series is covering Phoenix and Elixir in production. And I want to hear from Brooklyn a little bit about your background, the company that you're working at, how you got started with Phoenix and Elixir. You just give us the broad strokes.
Yeah, so got started with Phoenix and Elixir years ago, maybe 2014. Looked at Erlang prior to that. Very interested in functional programming pretty much from the starting of my career. And started using Phoenix, I believe, just a few weeks after 1.0 was released in production. Did a bunch of client work with it, was very happy with it, and sort of spread Phoenix everywhere that I could. Ended up teaching classes on it, workshops, doing corporate training, etc. These days, company that I'm at, we're doing more R&D in the blockchain space, specifically working on the Ethereum virtual machine and some pieces around that, especially around correctness. Yeah.
Very cool. And do you want to maybe give us a quick overview of some of the Elixir projects that you've put into production over the years?
Yeah, absolutely. So for clients, I've done scripts app for a little end is all in Phoenix. We did something for a local company here called Intersection Consulting that was looking for essentially a dashboard. Notarized, which is kind of neat. They have a system where you can get documents notarized instead of having to drive to some distant strip mall and wait in line to get something stamped. You can just have a little video pop up and they can look at your documents and do everything real time. So all the real time stuff there is in straight Elixir with. I think we used one or two pieces from Phoenix, but not the full framework. And then I've also done a little bit of backend work for Uber as well.
And do you want to maybe talk about Elixir a little bit and why you chose to use it on those projects?
Yeah, so Elixir, obviously, long history in telecom and real-time, soft real-time. So all of these projects had some real-time element in them. So, commenting, liking in real time, etc. Much more performant than Rails, which is what most of these teams were coming from previously. High uptime guarantees are nice to have, but weren't a strong constraint in these projects. But still helpful. And then it's just the developer experience is just fantastic, right? Everything just feels good. You don't get everything parallelizes very nicely. You don't get stuck into the same traps that people have been getting trapped in, especially with OO programming over the past, especially 10 years. So, and of course, a lot of people are looking to learn something new and develop their careers, and this is a nice, easy step to do that. So it's, Elixir is not the fastest language. It's not the safest. It doesn't have a strong type system. All these different things, but it fits a really nice point in the design space of being fun to use, very readable, performant enough, and really designed for more industrial applications, something that's not going to go down.
And Eric, feel free to jump in here with any questions or thoughts that you have. So before we started the conversation, we also sent you some of these questions that we'd be asking, and you sort of hit some bullet points there. I was curious if you could, because one of the number one benefits that we talk a lot about is the performance, but you're saying it's not exactly the fastest. I'm wondering, under what circumstances is it optimal to use a language like Elixir because of the performance, or maybe a better question is, when would the performance not be adequate?
So response times are good, but it's not really designed for fast turnaround, right? It's more designed for throughput, right? So, you have these wide parallel systems. It runs, I think, 20 times slower than C, for example, and you have much faster languages in the functional programming realm as well. Scala, Haskell, F#, OCaml, et cetera. Especially OCaml does very, very well. It's much faster than Ruby, Python.
I was going to add that, like, we came from a Rails shop, and so like seeing response times in like microseconds is like, sign me up.
Right. Yeah.
So
yeah, and it is great, right? So for like a web use case, it's fantastic, right? It is slower than say Node, right? But the experience is so much better, right? The tooling's great, everything comes out of the box. The documentation is really full and rich. It just feels good to use. And if you're doing this 8 hours a day, sometimes more, you want to use something that that you can really trust in and enjoy. And then in addition, you get the parallelizability, you can do lots of things with load balancing. If you take the time to set up a supervision tree, though, Phoenix kind of comes with a nice one out of the box, but you have nice uptime guarantees. You do have to watch for thrash in the system, but the server's not going to go down, right? And then you have the nice stories. It's fairly easy to sell to shareholder. So it really hits this nice point in the design space. So speed isn't everything. If speed was everything, we'd all be writing Fortran.
Or assembly.
That's great.
I also like that you point out that it's designed for 2019.
Yes.
I think that's a good...
Yeah, TF8 supports. We're going to be doing a lot of stuff off the CLI. Repl-driven development is huge. Just being able to pop in and really quickly test a couple things out, really important. TDD tools built in by default, right? It's just all the best practices that we have from today. And a lot of the Phoenix team comes from the previous Rail core team. And they're taking a lot of the learnings with them. And you can really see it.
Eric, do you want to maybe start asking some of the higher level questions, system level questions? I'm curious what Brooklyn's going to tell us about her experience there.
Sure. So I guess the first place to start, what have you used to actually host these applications?
Pretty much across the board, it's been AWS and a little bit of Heroku. So typically, doing a little demo or something quick. Heroku, AWS for actual deployments, both running directly on the server, and then also Dockerized because Kubernetes is the new hotness. So.
So for Heroku, do you just use a mix phx.serve? Is there anything fancier?
Yeah, so you do have to, it doesn't have support for Elixir straight out of the box. You do need a build pack, which is getting a lot better over the years. At the beginning, it was a little bit rougher, and it does have to build the whole thing. It wasn't caching, so it would take quite a while to do each build. These days, it's pretty straightforward. I even have, I believe open source on GitHub. I have a repo called Uprun, which I used as demos for when I taught classes. That gets hosted on Heroku, and so it has the build pack configuration right in there. We can just copy paste that. It's 2-3 lines.
And so you mentioned Docker. Is that how you typically deploy? Do you use any kind of from the Rails community? We had Capistrano and kind of stuff like that. Do you use anything like eDeliver, or is it just straight Kubernetes, whatever goes on in that world?
Yeah, so straight Kubernetes stuff, and that's typically coming from requests from clients who've Dockerized their entire infrastructure, right? And their DevOps team, has bought that whole way of doing things. So you wrap it and serve it that way. It makes some things easier, some things harder, right? You have to get the ports all wired up. I hear a lot of complaints from people on the Beam in general with Docker saying, well, it already does these things. And that's great, right? It's we have the automatic restarts and, auto scaling, all of that nice stuff, but it doesn't solve it in general. It solves it only for things on the Beam. So if your database, sitting off to the side, yes, you could have that supervised directly, but Docker's becoming the industry standard. So it's one less thing that you have to worry about as a developer, and you can hand that off to a DevOps team if you have one, which is great.
Yeah. Sort of going along with that, do you use anything like libcluster? I know there's Kubernetes built-in options to do clustering. Do you do any clustering, or is it each node is its own thing and it's load balanced above?
Yeah. So load balanced above, and then we've explored doing clustering for some applications, but it just didn't really fit for these, sort of more consumer apps, right? Especially if you're on AWS and you can just stick a load balancer in front of the whole thing, right, and just serve requests. It's just a very standard. It's cool that Elixir can do all this stuff for you. It's great, and means that you have less overhead, widespread of tools to learn. But if you already have a team that knows these things and has a way of doing it, it's nice that you can still lean back on the way that people are used to doing things, right?
Yeah.
Which is, again, this, nice developer experience, this DX.
Are you able to get any zero downtime deploys with your setup?
Yeah. So have looked at them, have done a couple tests just to see, how does this work? Is this interesting? It's very cool when it works.
Yeah.
Like it's pretty, it's very flashy, but it is a ton of work, right? Even in the simple case, when you can kind of, just use like the distillery based thing and it works, that's great. But as soon as you have anything even just slightly more complex, it's just, so if you can do a rolling deploy, do it. And that's great. I was even talking to Robert Birding, one of the original creators of Erlang. I was asking him, so, how are your zero downtime deploys going, right? Your hot updates. He says, it's such a pain, even for him, 95% of the time, just do a rolling deploy. And it's just easier. If you're working for Ericsson and you can't have your network switch go down, then absolutely it's worth the extra time. But, if you don't have a 9 nines of uptime SLA, if you do, maybe check that contract again and rewrite one. And two, taking a second or two literally to do a rolling deploy, it's fine.
Yeah. Early on in my figuring out Elixir, there's a book called Designing for Scalability with Erlang and OTP. And in it was like, you can do hot upgrades, but you're probably a small startup where no one cares if you're down for a second.
Yeah. Well, and even for some of these larger clients, right? So doing, App Store app, right? Lonely Planet trips. If that goes down for 50 milliseconds, no one will really notice, or they'll retry to upload, or, their comment will say, oh, no, that didn't go through. Please try again. And nobody will really see. It's not like it's happening once every hour. It's happening twice a year, let's say.
Yeah.
Yeah.
Eric, do you have any more questions on the sort of high-level system stuff before we move on to maybe a little bit lower level architecture kind of tools?
Yeah, I guess the last question would be how does this compare to, you've mentioned you've done some Rails stuff, like how does it compare in terms of response time, throughput, kind of anything about the two systems?
Yeah, so I get asked this a lot because especially when I'm teaching, people are coming in from Rails and they've heard that Elixir is the better Ruby and Phoenix is a better Rails, right? And really the trade-off is, yes, you have better throughput, but much better response times, honestly, easier testing, there's a huge number of benefits, but a smaller ecosystem, right? So there isn't a gem for everything.
Yeah, that's almost a benefit as well.
Yes, yeah. Exactly. It's mixed. It's a bit of both. And also being a bit of a younger ecosystem, though it's building up quite a bit more now. But, back in my day, walking uphill both ways, there was a lot of stuff to be built out, right? You could write error handling libraries, you could do JSON parsing, all the basics. And there's something exciting about that, being able to say, yeah, we're the dev shop that built, well-used library X. Yeah. Right. And it's a way to generate incoming traffic as well. Right. Anyway, this Rails mutation, right, that Phoenix has, it's the new Rails, also hurts because it works quite a bit differently. Right. And especially Elixir versus Ruby. Right. Really create an object, and that isn't what we have. Right. Or they'll start doing like, oh, well, I'm just going to, use a visitor pattern, like, whoa, stop, pump the brakes. This is a functional programming language, right? Use polymorphism, use recursion, find some simpler way of doing this that's encoded directly in the functions and doesn't rely on some conceptual map that you have in your head, right? And just do it directly, which is also part of why some of the open source work that I did was around specifically enhancing protocols and structs and going that direction. So this is Witchcraft and Algae, so that you can encode things very directly. You can essentially write a configuration and then run it, which is a very functional way of doing things, just to prove to people like, we can take your visitor pattern and then encode it in a data structure and then run the data structure, right?
So, Brooklyn, you just mentioned a couple of the open source libraries that you've produced for the ecosystem. Our next few questions are kind of more the sort of language level, architectural level. Can you talk about some of the libraries that you're using, toys that you've built? Explore some of those. I mean, I think when we first met, it was at the big Elixir Conf, and you were talking about your error handling library. So maybe we could start there.
Yeah, for sure. So error handling library, exceptional, which really came out of just from some real pain. We had to use a Erlang XML parsing library that was very under documented. So we had all of these different error states that could come out of it that were just a surprise, right? So there might be a different arity tuple, right? Different size, different length. Arguments swapped around, and the positionality of that was really painful. We also had a couple people on the team with a more Haskell background who wanted to have something that just sort of flowed, so you didn't have to take the output, stick it into a case, and then check each version. They wanted to handle all their error handling at the very bottom and continue flowing optimistically through the rest in the middle. So I took a weekend and wrote exceptional, which lets you do just that. So it lets you do a couple different styles of error handling and keeps you on the happy path. So you can act as if, or write your code as if everything was the success case, and then handle your errors later. Your errors are encouraged to be structs, so that you can pull different keys out. If you're using this in Phoenix, then if you eventually raise one of these structs, because exceptions are just structs, right? With special keys. So when you raise that, you can even give it a plug status, so it can raise a 422 or a 501 or whatever HTTP code cool. With a message for the user, which is that's pretty great. And then some ways of getting in and out of the more traditional systems. And that's probably the library. It took the least amount of time of the suite that I've written. And it's the one that I get the most fan mail about, because it just solves a basic problem of, I don't want to have to do error handling every 3 seconds. I just want to handle this later. I want to push the possible error states up to the callers because it has more context. This is happening in a helper. It'll have more context about what's going on, and then it can handle it more appropriately rather than raising and wrapping that in a catch, right? Or in a rescue. While we're in here, I guess, I alluded to this other suite of tools that I've written. I also bootstrapped up a lot of stuff from the Haskell and OCaml ecosystems as well, which a lot of people in Phoenix are more familiar with this style from specifically Elm, which is again Haskell-like. So eithers and maybes and results types and things like that. And then for anyone who has a Haskell background, there's also state monads and writers and what have you. But I always found working with protocols to be a little bit painful because the most common one, enum versus enumerable. I have to remember that my new struct needs an enumerable protocol, but then I will be able to make use of that. Why can't they just have the same name?
I'm not sure I actually knew that there was a difference.
Yeah. So enumerable is the they can't have a name space collision, right? So right. Enumerable is where you define it, and then enum is where you actually use it. So for each one of these, you'll need to define 2 modules, which other than just, don't repeat yourself is, you have this cognitive overhead of having to remember all this extra stuff. So I'm writing this library where you have to, you have one of these for lots of different things, for functors, things that are mappable or foldable or traversable structures, or monoids, so things that you can add together over and over and over again. And not have to worry about, they're always appendable, right? So that would have been a lot of this duplication. So wrapped that in a library to give it the same name, and you can define properties on it. So like this, you can always add more of the same thing onto it, like doing numeric addition or string appending, right? So you can define those properties in there as well, generate some test cases. basically, which then let us build Witchcraft, which has, the more classic, the things you hear from Haskellers about, monads and, and whatnot. So, and arrows and comonads and, all those buzzwords. And algae, which has the actual data structure. So it's algae for an algebraic data type, which can be used both for this style and then also as a nice way to build just a different syntax for building structs that reads nicely and doing nested structures as well.
And I guess to add on, because you just went through several of the libraries that you've built, and you're using most of these in, I imagine, a Phoenix environment, like you're building on top of Phoenix applications, yeah?
Oh, yeah, absolutely. The primary use case, because a lot of people hear that and go, ooh, that sounds like way more complicated than it needs to be. The main use case for this is doing things like, you have a map, enum.map. But I want that to be, I need to use a bunch of things in parallel. So we have an async map in Witchcraft where it works the same way and things just happen in parallel. You don't have to wrap everything in a task.async. So it's just keeping it a little bit cleaner, a little bit more about the semantics rather than the operational, I will do this, then this, then this, then this, right? And kind of keeping the flow more. So using that in Phoenix, because it's totally, has nothing to do with HTTP, stuff like that, you can absolutely use it in Phoenix or any Elixir project. These are the basic building blocks, really, of FP, and especially the one that I didn't mention, Quark, which has all the classic functional combinators or classic functions in it that I was actually really surprised didn't come in the standard library, right? Flipping arguments or having a constant function, having something where you can do querying, all of that stuff was surprising to not have. So we added it in, and it turns out to be very useful in lots of places in Phoenix too.
Very, very cool. And I'm going to give us a time check here. We've got a few minutes left. So Eric, if you want to take us through our last few questions, and then we'll give Brooklyn a chance to tell the audience where they can find her. And you've got a ton of videos online, like lots and lots of conference videos. You're extremely a great contributor to the community, so we'll plug some of that as well. But Eric, do you want to maybe take us through some of these closing out questions?
Yeah, I guess so. For our last two questions, are there any cool features of OTP that you might be using? I don't know, any advanced supervisor stuff or anything like that?
So haven't really used too much of the advanced OTP stuff other than playing around, right? For day-to-day stuff. Yeah. Haven't found the need for it, though it's nice to know that it's there. Really, really like, what's it called? It's completely, I'm blanking. The Flow library, GenStage.
Right.
GenStage is very, 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 but for most things, like if you're just setting up, the first version or an MVP of an app, you probably won't need most of that stuff. And the built-in supervision in Phoenix is sufficient. And then tweaking it is usually pretty straightforward. OTP, because people usually think of OTP as the gen libraries, but it's actually it's the entire platform. It's the virtual machine, the language itself, all this stuff. So I will take this question in a bit of a different direction. I love that Elixir has borrowed a lot of the cool stuff from a variety of different languages, including macros. Right, from this. So language is somewhat iconic, and you can build extensions to the language as much as you need or want. On two rules of Macro Club: 1, don't use macros; 2, don't use macros. But if you're on a deadline and you're writing a lot of boilerplates, you can stick some of that in macros and clean it up and move very, very quickly, and then go back later and break it out. Right.
You're talking to the Smart Logic macro king over here.
Amazing. Remote high five. Yeah. Yeah. Like people discover macros and then just go wild with them. So, I mean, remember the 2 rules of Macro Club. But super, super powerful and very easy to write parts of your application as a DSL. so that it's very readable, your business logic, and do some domain-driven design that way is very, very nice. So would recommend. And then, having people poke around in as many of the dark corners of the standard library as possible. People immediately go to enum, look at the rest of it. There's a lot in there that people don't explore.
Yeah, especially the SSH server.
Yes. Yeah. Yeah. So something that I usually do when teaching, will build up a fully peer-to-peer CLI chat client from scratch. And it just blows people's minds, but it's like one module. It's literally a gen server and you're done.
Yeah.
We can talk about that on the text podcast that Eric's about to start.
Awesome.
And I guess our last question, if there's one tip that you could give to developers who are or will be soon running Elixir in production, what would it be?
Number one, has great developer experience. Have fun, play, explore. You don't have to use all the features just because they're there, which is what everyone does at first. It's this big toolbox with lots of things. Play around, but just use the stuff that you need, and you'll be happier for not having introduced lots of moving pieces. But really do go spelunking into those tools on side projects for sure.
Great. This has been an awesome episode. Brooklyn, thank you so much for joining us. Last thing before you go, where can the audience find you? How should they contact you? Why should they contact you or not? Yeah.
So I am Xpede pretty much everywhere on the internet. That's EXPEDE. So Twitter, GitHub, etc. Email, pretty straightforward, hello@brooklynzelenka.com. Drop me a line for pretty much anything. I'm usually, fairly good at getting back to people unless it's like a larger question. Like I have one person asking, how can I use category theory, which is, an aspect of math in my day-to-day programming? I'm like, you know what? I'm going to have to wait on that one a little bit, but usually get back to people a little bit faster than that. And even, any questions about Elixir, my experience with it, other tools that they might find useful for plugging into their application. These days, I'm working a lot in blockchain. People are curious about that. Always happy to talk about that as well.
Yeah, Justice is our blockchain fanatic.
I know. We almost had a blockchain conversation here instead of Elixir in production. But we have a theme and we're sticking to it. Elixir in production. This has been a conversation with Brooklyn Zelenka. Everybody, thank you so much for your time, Brooklyn.
Thank you for having me.
Once again, this has been Smart Software with Smart Logic. Join us for our next episode as we continue our series exploring Elixir in production. And remember, alchemists, keep on trucking.